Hello, good people. So this is going to be the video talking about how to use JASP for Chapter 17 in your SPSS book. So, yeah, I don't know why I labeled it Chapter 14. I'm going to relabel that. It's Chapter 17 in your SPSS book, but it refers to Chapter 14 in your textbook. So Chapter 17 in your IBM SPSS textbook is the chi-square test of independence. So let's go from start to finish here and get it done. All right, so let's open some data. Again, you should have access to all these things via Canvas. It's going to be labeled Chapter 17 data. And so you got patient, visitors, and treatment. So again, read through the context of the situation, the research situation that you're talking about. So you've got a psych student intern, volunteering in a nursing home, taking an aging course, watching how nursing home staff treats patients, and this person's also noticing how often certain patients are being visited. And so this is what's going on here. So we got patient here on the left side. Basically, it just, again, is repeating just patient number 1 through 30, right? We got 38. Got 38 patients, and then we got visitors, and we got 1, 2, and 3, and then we got treatments, and we got 1, 2, and 3. And so at that point, we've got some, what do these numbers represent is really what you should be asking yourself. And so according to the setup, again, so if we're talking about visitors, we've got for visitors, 1 equals frequent, 2 equals occasional, and 3 equals rarely. So this is sort of how many times people visit them. So 1 is frequent. So if you're looking across this, patient number 1 is classified as having frequent visitors. That's what that translates into. And 2 translates into occasional, and 3 translates into rarely. But then treatment, what does treatment refer to? Treatment, number 1 is excellent treatment. So that person has been rated excellent as treatment. 2 is fair treatment. And 3 is poor treatment. So 3, again, is rarely and poor kind of stuff. So that's what those sort of things mean. And so if you're doing this in SPSS, follow along in the textbook. It's pretty straightforward for the syntax method, or not the syntax method, but the point and click method is probably going to be the easiest. But it's going to be a little different when it comes to the JASP kind of stuff. So if you look across this JAP stuff, there's no chi-square option. So if you notice that, you're like, all right, so what do I do now? What's interesting is that it's classified under frequencies, and it's called a contingency table. So don't really ask me why. But that's where a chi-square can live. So we got frequencies, and we come down to contingency tables. And so if you click on contingency tables, you see something over here on the right, or on the left. You got rows and columns. That's very similar to, what you were learning about in Chapter 14 textbook about rows and columns and that kind of stuff. So what we first want to do is move things over to rows and columns and that kind of stuff. So we've got visitors. We can go that over the rows, and you see it doesn't work. And you go over here, treatment, and you can't do that in columns and that kind of stuff. And you start thinking to yourself, why can't I move things? If you look over here in this rows and columns in the bottom right of this white box of the rows, you see these 2 little pictures, same thing with columns, that kind of stuff. What does that translate into? That translates into type of data that it's willing to accept. And so if those little circles are nominal data and those little bar charts are sort of ranking data, this doesn't look like any of those pictures. Patient, visitors, or treatment, this looks like a ruler. And so what does that translate into? It translates into ratio interval kind of data. So what does that mean? We got to reclassify our data. So you just pull this over so that we can have access to the data here again. And we got to change this. So right now it's the default is a scale, but we don't want ordinal data because it's not, these things aren't necessarily, they're sort of an ordinal, but it's just easier to use them, consider them as nominal. And the same thing with treatment. We got to change that to nominal. And so now that we've changed that, we can slide this away because we don't actually look at data anymore. And you can put visitors over by row. You can put treatment over by column. And so what do you got going on here? This is the actual numbers. So this is just basically putting this in a little table for you. So visitors, what does that mean? So we've got treatment, we got visitors. So visitors 1, 2, 3 here on the vertical, treatment 1, 2, 3 on the horizontal. And so we got total all the way in the bottom right here. We got 39 patients. Okay, so we got 39 total patients. And basically this is just organizing stuff. So the number of people who had treatment number 1, if you're looking at treat, that column 1, you go all the way down, you got 11 people who were treated at a 1 scale, which was what? Good. Treatment 2 was fair. We got 14 people who were treated fair, and treatment level 3, we've got bad treatment, and then we got 14 people there, and we go all the way across to do the cross kind of thing with the visitors in that very first column. Visitors 1, we got a lot of people. We got 13 people being visited frequently, 2 people, occasionally, and 3 never kind of stuff. So it's just organizing this information into this table and that kind of stuff. And it does give you a chi-square test, which is what we're going to be looking for. But again, to quickly review what a chi-square is, chi-square test of independence is finding out if what was expected is equal to the obtained. So again, if you don't know what I'm talking about, please go read chapter 14 in your textbook so that you can understand what I'm talking about here. But these are the obtained stuff. This is the empirical data. Like, this is the data that's over here on the left. This is what we just, sort of hid. This is just the real data, that kind of stuff. What's expected is based off of math. And so this is another kind of cool thing about chi-square, is that chi-squares typically are only using nominal data. So that's one biggie when it comes to chi-square stuff, is that everything we've been talking about since null hypothesis testing has been sort of scale data, quantitative data. This stuff is qualitative kind of data. It's nominal kind of data. So we can do a chi-square test. We can do null hypothesis testing using qualitative data, using nominal kind of data. So that's what this is. And what's going on here is that we don't have equal numbers. We've got 13 1s, 13 2s, 13 3s when it comes to visitors, but I only got 11 1 treatments. I got 14 2 treatments, and I got 14 3 treatments. Classified, level 3 kind of thing. So they're unequal, but that's fine. If you remember when we talked about factorial ANOVA, we needed these cells to be equal. Well, in chi-square, they don't have to be equal. Why? Because we just do the math to calculate what we would expect there. And for you to sort of understand what I'm talking about when it comes to math should say there shouldn't be a relationship between the number of visitors somebody gets and how they're getting treated at the nursing home. There shouldn't be anything. So what does that mean? If I got 39 people in my study, and I've got basically, what do I got? 9 little subgroups here. 1 1, 1 2 2 2 3 3. So I got 9 little subgroups here, and I got 39. What does that mean? I should probably have what? What's 39 divided by 9? Like 6? No. Wow, I'm really bad. 9 divided by 39 is pretty damn close to what? 3, 4? 4. So I would expect roughly 4 people in each of these groups. Well, that's not what's going on here. Like, again, if you're just doing math is expected kind of stuff, or a test of independence, I should expect around 4 people in each of these groups if there was no relationship between treatment and visitors. If I'm looking at this data right here, these do not look like 4s. There's along this diagonal 9, 10, 11, and then I got a whole bunch of 1s and 2s and other areas. That is not what's going on here. So again, the chi-square test of independence is a null hypothesis test to find out, does the expected match the observed? And you start saying, all right, well, what do I got going on right here? I'm only looking at the observed. Well, is there a way for me to find the expected without trying to do the math in my head? Yes, there is. So what can I do? I can go to cells, and I can click on the expected. So now I got the expected count. And you see what I'm saying? Math was telling me I should have around 4 people in each group, and that's kind of what that's saying. But that's not what I'm getting. I'm getting 9, 3, 1. I'm getting 1, 10, 2. I'm getting 1, 1, 11. Those are not all 4s. So there's a discrepancy going on there. There's something weird that's going on there. I expected things to go a certain way. They didn't. Why is the real question. And that kind of stuff. So this is really what you're looking for. I mean, this is it. This is all you really, really sort of need for this particular data. So what do you need to look at? chi-square test on this very bottom here. We got a chi-square test. We got a p less than 0.001. What does that mean? Again, we reject the null if our p-value is less than 0.05. This is way less than 0.05, so we got to reject the null. What is the null here? The null is observed is equal to expected. The expected were a bunch of 4s. We did not get a bunch of 4s. That's why we say that they're not equal, which means what? It means that these two things are related. It means they're not independent. Treatment and the amount of visitors have some sort of a relationship there. There's some sort of dependency going on here. And I need you to interpret that. So when it comes time to interpret, this is what I want you to be able to get from the analysis from the JASP. You need to be able to figure out how to get this p-value, this less than 0.01. You need to figure out how to get these counts and the expected counts. When it comes to interpreting what's going on here, you need to interpret where the discrepancies are the largest. Can I find discrepancy largest? I don't know. Yeah, don't worry about it. What I want you to see is where the biggest discrepancies are. So what's going on here? So I got a discrepancy. So look at this 1-1. So I got treatment 1, visitors 1. I actually have 9 people in this group, but I was only expecting 3.6. So what does that translate into? That's about 5.5 different. Here there's the 2-1, the visitor 1, treatment 2. I'm only off by like 1.6. But over here in this treatment, visitors 1, treatment 3, I got only 1, but I expected 4. So that's a difference of about a 5. So that's a pretty good difference there. And that's what I'm asking you to look for. Look for all the biggest discrepancies here. So again, I'm looking at this 1-1, visitor 1, treatment 1. That's about a 5.5. If I look at treatment 2, visitor 2, that's also about a 5.5. If I look at 3-3, treatment 3, visitor 3, the discrepancy between the count and the expected count there is about 6.5. So this is going to be the biggest discrepancy here. So tell me what's going on here. I expected only 4 people to be in the group of visitors 3, treatment 3, but I got a lot more people there. So what are those groups? 1 second. Hold on.